5 years after Philae landed on Comet 67P, the Rosetta mission is the gift that keeps on giving. Scientists are still analysing data from its instruments and delivering data to an archive as a resource for the future. This includes data on Comet 67P's diverse landscape, coma and plasma, the ionised gas coming off the comet.
Regarding the plasma, I think we were very surprised how different Comet 67P and its environment is from all the comets that we have visited before. So basically what we are looking at with the plasma is an interaction between the solar wind, which is a magnetic field and charged particles, and the charged particles that are developing around the comet, right? So you start off with a neutral gas and you ionize it, and these particles interact with the solar wind. From our previous experiences, the number of particles was very high, but with Rosetta it actually wasn't. So I think the biggest surprise was that basically a lot of our predictions were wrong. But this is good because then the data tells us, okay, maybe you're missing something. You missed including this process in your models. And now we've had the time to actually include these processes in our models and improve our science that we get out of it. And I think that was the most fun part as well about doing the science with Rosetta.
The Rosetta instrument, a spectrometer for ion and neutral analysis, examined the composition of the comet's atmosphere and ionosphere and investigated the gases coming off the comet. It discovered organic molecules and a complex form of carbon in a series of important findings.
The first one was the deuterated water. So we showed that the terrestrial water cannot come, at least the bulk of the terrestrial water cannot come from comets. Then certainly the oxygen, the O2, which was completely unexpected and which points to a primordial origin in pre-solar of O2 and probably many other species as well. Then we have found the noble gases, especially xenon isotopes, which tell us that probably the terrestrial atmosphere got some cometary material because the xenon in the comet and our atmosphere are similar. And from that we can calculate how many comets probably hit the Earth and how much organics were brought by comets to the Earth. And that's a lot. It's really a whole lot of organics. And this could have sparked life on Earth.
Comet 67P orbits the Sun every 6.5 years, so it will be observed again from Earth in late 2021. And this led scientists to consider something new.
What this inspired us to think about is about how can we see how can we really get a pristine comet? How can we see what the comet looks like before it meets the Sun? And that's led us to talk about this, to propose this new mission, which we now have, Comet Interceptor, which is a different type of mission entirely from Rosetta. It is a fast flyby mission, so we don't orbit the comet, we don't stay and follow it. We encounter a comet at high speed, fly past it, and get all of the data we can in only a few hours.
Comet Interceptor will target a new comet that has never entered our solar system before. It could also examine something like Oumuamua. Discovered in 2017, it is the first known interstellar object to have visited our solar system. And so Rosetta's ongoing legacy will inspire yet more scientific discoveries in the future.